Okay, welcome to lecture 4 of fluid mechanics. In today's lecture, I'm going to talk about hydrostatic force acting on submerged plane surfaces. Okay, so first of all, you know the definition of hydrostatic force. We already talked about it, and in brief, when the water is at rest, like water in this tank or water in this reservoir or in that reservoir, we said this is static flow, stationary flow, and therefore any kind of forces resulting from this amount of water is called hydrostatic force. Okay, and in this lecture we are going to see how we can calculate hydrostatic force acting on plane surfaces. The plane surface can be either horizontal, like the bottom of this tank, yeah, or vertical, like this dam. You see, this is a wall, a dam, and there is a body of water. Therefore, as a result of pressure of this water, there is a force acting on this vertical wall. And it could be oriented wall, like earth-fill dam. Here we have weight dam, concrete weighting dam, and this is earth-fill dam. Therefore, we can find amount of force as a result of this body of water on it. So we first start with studying the resultant force acting on horizontal plane. Okay, this is my tank. I have a water, a liquid or water in this tank. The depth of water is shown by D, and as we talked, as a result of this water, we will have pressure at any point in depth of this water. So for example, we already talked that pressure at the top is just atmospheric pressure. You remember we said this top layer is called free surface. And if we think relatively, there is no pressure at the top, or just atmospheric pressure we have. And when we go deep into the tank, what will be happen? The amount of water increases, and therefore weight of water above each point increases, and consequently, and as a result, pressure increases. And we already saw that pressure at any point equals to gamma times H. Let's ask you some question. And please, one of you tell me what is the pressure amount at this point. Who knows? Just answer. Any answer? Depth is D, therefore pressure here should be P equals to gamma times H. In previous session, we studied that P equals to pressure gamma times H. Therefore, pressure at this point should be gamma times D. So how about this point? What's pressure here? Open your mic and talk, please. Anyone? Pressure at this point?
It will be the same.
The same because?
It's all points on the bottom line.
Yeah, all the points are on a horizontal line or niveau surface we already saw. So pressure equals to, if here, if this point is at the middle of tank, what should be pressure here? Pressure at this?
Gamma times D over 2.
You are right, gamma times, because it is at the middle, d over 2. So do you see that you know how to calculate pressure at different points? How about calculating a resultant force? Okay, let's come back to this bottom. That is my question here. What is the resultant force? We will show resultant force with Fr along the bottom of wall. You all agree that pressure here equals to gamma times d, yeah? And you said that all the pressure at different points are the same. So we have such a distribution of pressure. Assume this is P, okay? And the value of P equals to gamma times H. So how we can find force if we have pressure at one point? Yeah, the easy answer is this: pressure times area. Force equals to pressure times area. And this is P shown here. This is P, constant P. And without thinking of this slide, let's follow here. Then I will explain more this slide. So I have pressure. It is uniform. So force equals to P times area. And if from here to here is L, length, and if you know the third dimension of this tank, yeah, I have, for example, water also here, and this dimension is, let's say, for example, V, and it denotes width, okay, denotes width of tank. Therefore, you can say that force acting on the bottom, or Fr, equals to P times area. P already found, gamma H or gamma D times area. What is the area? L times W. Yeah. So you can easily use this general formula: pressure times area equals to the force in for solving problems of finding resultant force on horizontal surfaces. The fact behind that you can easily solve this problem is this one. P is constant. You see, P is constant at any point at the bottom. However, in case that if the P is not constant, you cannot use this equation. Okay, so let's see the other way, or the general way that we can find or solve this problem, and it is use of the net force or force force diagram, free diagram. You see, from water we have Fr. Sorry, we don't know Fr, and we are looking for Fr. From body of water, we have such a pressure, uniform pressure distribution, and it is called, for example, P at the bottom. In addition, from upside, we have atmospheric pressure. You see, from top, we have atmospheric pressure. And atmospheric pressure, you know that it is also uniformly distributed on the top. This is PA, okay? From the bottom, outside of the tank, we have also atmospheric pressure. So we can find net force if we write force balance at Z direction. To write force balance, you can say like this: Fr, resultant force, it is equals to PA times the area of, this is again, assume this is your tank is in that, sorry, because of ugly drawing. Anyway, if you have the area, it would be, I mean, this area of bottom, pressure times area minus PA, again at the bottom, we have PA plus gamma D, this value. Again, it acts on the area. It should be equal to minus the pressure to the bottom, which if you simplified it, you will see that pressure equals to FR equals to gamma times D times area. The same with here, I already wrote you. Okay. So I would like to summarize in a very easy sentence. Pressure at bottom or pressure at any horizontal surface equals to force at horizontal surface equals to pressure at any point of that surface, at any point, because we know that it is horizontal, therefore pressure uniformly distributed, multiplied by area of the surface. So, do you think that now you can solve this problem? This example says that there is oil stored in a storage tank with a circular cross section. It has a circular cross section. Density of oil is given, and calculate pressure force, also called resultant force, at the bottom of tank. How we calculate it? Just find pressure at any point at the bottom. Okay, Makbula, what should be the pressure here? At the bottom, for example, P equals to just pressure, gamma times H. What is the gamma?
1850.
It is rho, yes.
800.
850 is rho, okay?
Yes.
So to calculate gamma, we should multiply rho by G, yeah? Rho G, therefore H, rho G H. Okay, so 850 times 9.81 times H, or depth of the oil, is 7. Therefore, pressure is here. After that, we just multiply pressure with the amount of area of this circle. And as you see here, the area is P R square divide PD square, sorry, P, just a minute, P, it should not be 2, it should be 4, sorry. Sometimes when you took some examples from internet, there are some problems like this, yeah? The area of this area, this yellow area, equals to P R square, not P R square divided by 4. So the answer should be corrected, okay? If they divided by 4, you should be correct. So we said that pressure at any point at bottom here, here are constant, and the value equals to gamma times H. Gamma means rho times G times H, and then pressure should be multiplied by area. And area is P. If you have R, PR square gives area of the circle, and from there you can find amount of magnitude of resultant force. Any question? No. So I have this question, another example. And in this example, we have two different fluids in a tank, and also we have interior pressure in the tank. As you see, we have a gauge here and shows that air pressure at the top equals to 90 kilopascal. And the question is, what is the resultant force acting on the bottom of tank? Okay, how should we calculate this force? To solve such problems, we should add pressure or resultant force from different liquids. We can calculate them separately and add together. Anyway, we know that pressure or force at the bottom equals to sum of the, or equals summation of any kind of pressure or force from any kind of pressure that we have here. You see 90 kilopascal, 90 kilopascal, there is a pressure here in the unit of kilopascal. What is the unit of Newton? The unit of force is Newton, yes? F equals to P times area. This is our general formula. Okay, we have pressure here, and this pressure acts at entire tank. That pressure acts on this and also acts on this liquid and also at the bottom. Therefore, first one element of F is this one. So I can write in that way, total resultant force FR, total FR equals to, I want to say that F of the, here if the air, assume it is air, we can say that F of air F of second liquid and plus F of the first liquid, yeah? Because first it is row 1, I said first liquid, second liquid, and third gas. For gas, pressure already given, and for each of these F, we should use this formula, yeah? So R is already at hand, R is already at hand. How it has hand, you should know the R, yeah? Assume R equals to 2 meters. Yes, because in this question I don't see R, therefore I assume my R is 2 meters. Therefore area is at hand, and I'm going to solve in that way. So FR, or resultant force, equals F of air equals to P of air. What is the P of air? 90 kilopascal. Okay, from now I will use all the let's say, let's continue with Newton, not with Pascal, not kilopascals. Therefore, I can multiply it 10 to the power of 3. Area already calculated. Let's calculate area here. A equals to P times R squared. Okay, what's the value of P times R squared? 12.56. 12.56 meters squared. This is my area. So let's assume this, for example, 12.6. So I can write here 12.6. And this is the resultant force just because of air, compressed air here, plus F2. For F2, I need to do what? Gamma. I find the pressure at the here, entire pressure acts at the bottom of this liquid, and therefore I should multiply, I say gamma of 2 And from rho, I can use here 600 rho g times 9 to the power 9.81. It is gamma h 2 meters, gamma h times area for the same area is constant, and actually my area is not this area, always is bottom area, because all this force we are looking for this force acting on this area, again times 12.6. and for the last fluid, now rho 1 is given this value, rho g 9.81, rho g h. What is the height of the rho 1? 5. Rho g h times area. And this will give you amount of resultant force in Newton. So you see that when the plane is horizontal, you can easily use this formula, F equals to P times area, and you can find pressure at any point of the plane, either here, and then multiply by the area. Any question? So no matter what is the shape of area, it could be rectangular, it could be circular, or any kind of shape. Okay, now let's see how we can solve or find the magnitude of resultant force when our surface is vertical, not horizontal. Before going to that, let me ask a question about this figure by attending you in this. Selin Chalabi, could you please open your microphone? And how are you, Selin? Selin, here you see a dam, yes? You see a dam. This is concrete dam, and here we have a reservoir, and the depth of water in the reservoir is 96.5 meter. Okay, nice. And this is the ground. And can you say me what is the pressure at the ground? Just pressure. This is water and height is given. What would be the pressure? Gamma of water should be multiplied by the height of the water at the reservoir. Or you can say 96.5 times 10 to the power of 4. So pressure here is at, and we already said that at the bottom, pressure is constant, and the value already found. So Malike, what would be the relative pressure at the free surface here? Relative pressure is, your microphone is closed, maybe. I don't hear you. It is zero. It is zero. If you are saying zero, thank you. Yeah, it is zero. So we see that we have pressure at the top 0, at the bottom 9.65, 96.5 times 10 to the power of 4. Okay, Makbule, what is the pressure here at the middle point, at the middle of the reservoir?
96.5 over 2.
You are right, times 10 to the power of 4 times gamma times h divided by 2. So you see that at this vertical level, at the top is 0, at the bottom is the maximum value, at the middle is half of the pressure, and as you remember, we already talked that pressure at stationary fluids varies linearly. Here is the minimum. For example, here is the maximum pressure, and here is the half of the maximum. And therefore, as I already said, the pressure varies linearly. So at each point, you see we have different pressure which is not uniformly distributed. Therefore, you cannot say F equals to, you can say always F equals to P times area, but what is the P? Here we have 1P, here is 0, here is maximum, here is half. Therefore, we need to adjust our formula, or we need to find a P, a kind of P that represent this non-uniform distribution of pressure at the behind the dam. So as you see here, again we have uniform distribution of pressure. The maximum as bottom, as the minimum is here, equals to 0. And our question is to find the resultant force. From static, you can find this resultant force without any thinking about what I'm going to talk here. If it is pressure, yeah, a kind of pressure is a kind of, for example, tension. You have this pressure. You know the value here, the value of the maximum here. If it is, for example, let's say if it is from here to here is H, P max P at the bottom equals to gamma times H. Yeah. So can you find the magnitude of equivalent force for this distributed tension? You know, in static, you say, for example, net force equivalent force of this tension distribution. Yeah, it is equal to the area of this triangle. Let's come back here. Force equals to pressure times area. But here pressure, you see, is not constant, and we should think about this term. And now I'm going to show you how I can find resultant force, this F, in general, without thinking of your knowledge of static. Okay, in general, I'm going to find the F, then I link it to your previous knowledge. Okay, I assume this wall like this is my wall. Okay, it has a width this side, means this side. Okay, width this side from here to here is W, shows width. The entire H and equals to H, you see here H, I have H, and yeah, let's say it shows here entire depth, entire height of the wall, but water surface or free surface is a bit below the edge. No, not matter for us for now. Anyway, I have a water from this level. I have water from this level or this level, and I'm looking for the magnitude of F as a result of this flow. So to solve this problem, because I don't have a uniform uh, um, pressure, and I know that pressure varies at different point, I should concentrate on a small section like here. Assume this, I'm thinking about this just a small depth, this point, okay? And if you consider this, you know that this tank or this wall has another dimension, huh? VW, this is our W dimension, okay? This point is here, and I have a small strip area on this wall. For example, it could be, for example, uh, assume now I'm the in the bottom below the water surface, and I think about this strip, a very small area with the height of dy with the height dy. You see, this is my dy, this height, I mean, from here to here, it's dy, and length of or w. And now I would like to find resultant force acting on this. I mean, I'm also, I said this is distribution of pressure. When each of these pressure multiplied at area like this, and now this is not a point, it is a very small area like here, it gives me lowercase f, or f acting just on this strip, okay? So because now I can find f, yes, but it is called df because it's not acting at entire area, acts just on a strip, df. I can say that instead of f equals to p times area, as I replaced area with strip, I replace this area with strip, I can use dA, which shows this area, this dark blue area, this area. And at this point, I have value of pressure, yes, because from here to here, I can say this is y, as here written, okay, y. So at this point, I know the pressure. Pressure equals to gamma y, yes, gamma times y at this point. Therefore, I can use this formula. Instead of I have pressure, instead of force, I can find dF, as I told, because we just consider differential area or strip. And therefore, you can say that dF equals to, this is P times dA, as written here. dF equals to P times dA. So I found this dF. Because P is at hand, dA already at hand, dA equals to W. I know the W. The length of dam, and dy is this small depth or small height dy. It could be, for example, let's say 1 millimeter. This is just an epsilon bigger than 0, because when it is 0, it is not area, it is point, or it is nothing, but when the value is epsilon, it can be considered a stripped or small area. dF equals to P times dA. Instead of P, I can use gamma y, and you know that gamma equals to rho g times y. Now you have dF. Now you have this dF. And to find the F, you need what to do? You should add all these dFs together. Each of these um, arrows shows a dF, a small force acting on one strip, and this strip, this strip, this strip. If you add all dFs, it gives you F. Or when to do some just summation, what you generally do, you take an integral of dF. Okay. If you have dF, just take an integral of it from 0 to h to find the magnitude of total F. Yeah. So F equals to integral of rho g means gamma y w dy. I put this. Or F equals to integral of dF from 0 to h, because you see F varies from 0 up to h. You see that gamma of liquid is constant, always 10 to the power of 4, so gamma can comes out. Width of the wall is also constant. It could be taken outside of the integral. And my integral will have such a form. F equals to gamma w times integral of y dy. And integral of y dy is 1/2 of y squared. So you see that y varies from 0 to h, and if you put the value of h on the y, this answer should be like this: F equals to gamma y over 2 times area. What is the area? Area is w times y, yes. W times y equals to area. Which area? Entire area. Area of this wall from 0 to h. Actually, not entire area, the area of, you can say that, you see, this h is correct. The water surface, not this one, not entire wall. The depth of water times the width of that. So I can say that instead of y divided by 2, I can show it by y bar. F equals to gamma y bar times area. And this formula seems very similar for the mother formula, yeah? F equals to pressure times area, but here, instead of pressure, I have gamma y bar. And from the previous lecture, you know that pressure equals to gamma times the depth of, at any point, gamma times depth of water at that point. So here I have y bar as a depth that I should consider to calculate force acting on vertical surfaces. Actually, instead of gamma y bar, we can write PC, which means pressure at the centroid times area. Again, we have very simple formula to memorize it. And you, from the beginning, you know, F equals to pressure times area. But when the surface is vertical, we know that pressure varies. So in which pressure at which point should be considered? Pressure at centroid. which here for this rectangle wall, centroid was at the depth of y bar or half of the depth, and centroid or center of gravity is the geometric character of any shape that you can easily find. Or centroid here is the center of area. Here is center of area, and if the density of the density is constant, center of gravity will be the same with the center of area. Okay, any question? No. So I think now with that explanation, I can find the answer of this question. The question says, determine resultant force acting on the dam shown below, and the width or width normal to the screen equals to 36.5 meter. So I can use the simplest form of equation that I derived. F equals to pressure times area. The plane is perpendicular, vertical, sorry, the plane is vertical. Therefore, pressure should be confined at the centroid. I need to know where is the centroid of this wall. As you already saw, the wall has the shape of rectangular, and centroid is half of the depth, half of the height of the wall. Therefore, I can say that pressure times area. Instead of pressure, I should say gamma h times area. F equals to gamma of water times h of the centroid. What is the h of the centroid? Half of this depth, as you see here, and times area. Area means this value times to the width, 6.5 times to 36.5, and if you do the mathematics, the force will be this value in terms of kilonewton. Okay. Okay, any question? No question? So let me, before going to the last part of the forces, which is force acting on oriented surfaces, let me summarize in very easy language. We are going to find force acting on a plane which is submerged in water. I said that if the what you should do, you should find pressure and multiply it by the area, because force equals to pressure times area. Okay. Now finding area is easy. What is the shape? You know the area of different shapes. The problem comes or change to the question of what pressure and where is the pressure. When the question is about horizontal surfaces, horizontal surface, we know that in horizontal surfaces, area pressure is constant at any point in a niveau level. Pressure is constant, okay, any niveau level. So no matter you find pressure at this point or this point or this point or this point, pressure is constant, and therefore one value of pressure, which equals to gamma times h, would be enough to solve problem. Okay, therefore F equals to pressure times area. Pressure equals to gamma times h of the H is depth of water above your plate or plane. Now, when the problem is vertical, when the plane is vertical and water is in one side, liquid is one side, we saw that pressure is not constant from top to bottom of the plane. And we know that it increases linearly from top to bottom. Therefore, we cannot simply say pressure times area. We should say pressure of which point. And in this example, you saw that the point is centroid. Centroid of plane. Centroid means center of area. Center of area of plane. If it is rectangular, the wall is rectangle, you know that centroid of rectangle is the middle of the rectangle. Or centroid for a circle is center of a circle. Do you remember what is the centroid of a triangle? Do you remember where is the centroid of a triangle? It is 1/3 of height of the triangle from bottom, yeah, from the base. Centroid of triangle is 1/3 from the base. So just let me show you this, then continue. Okay. Just for your this point is centroid of triangle, which always, if from here to here is edge, from here to here is 1/3 of edge. By centroid, I mean such point. And for example, other shapes, you know its value. If you don't know, no worries. I will provide the a centroid table in this presentation. Now let's continue with the calculation of resultant force. I solved this example, maybe. Yeah, I solved it. To plane surface, but let's have a 10 minutes break. You can summarize again what you learned, then I will continue with this part. Okay? So I leave the session for 10 minutes, then we'll join to you. Stick around. See you. Bye-bye.